All right, welcome everyone. Okay, hopefully this will go pretty quickly. This particular lesson is entitled Quadratic Functions and Transformations. I don't have my slate pad with me, so we are just going to kind of have to make do, but hopefully we'll be able to follow along with this pretty easy. So let's just go ahead and begin. I'm just going to move this over here so hopefully it stays out of the way. Okay, so the first thing we're going to be doing here is we're going to be looking at some vocabulary and reviewing. So the first thing they ask us to do is they ask us to circle the vertex of each absolute value graph. Okay, and so you have to know what vertex is, and vertex would be what? It would be the point, lowest or the highest point, depending on whether your function is opening or closing. And so I'm going to go here and I'm going to find me a little circle. Okay, and since they asked me to circle, so hopefully you got this. Vertex is right there. Let's see. Alrighty. And then here, it's right here. Ah, that's what I want. Okay, let's undo that. And I got what I wanted. There we go. And then I got another vertex right here. We're going to undo that one. And let's see if we can get it in. No. So let's try it here. There we go. Perfect. Okay. So there we go. And that's how you identify your vertex there. We're going to, let's delete that one. And let's make it one that's going to show up a little bit better. And there we go. So it's right inside the circle. Okay. So hopefully you got that. Let's move on. Okay, so now we're looking at our vocabulary. So these are some of the words that we have. One of them is parabola. That's what this particular function is. Now notice that these are opening up and down. Also notice they can open left and right, but we're just focusing on opening up and down. Okay, so if you're talking about a parabola, some people call them quadratics. They're a type of conics, and what it is, you take a cone and you slice it a certain way, and that's how you get these different curves. And there are four: parabola, hyperbola, ellipse, and circle. Okay, and so when you're working with these conics or these quadratics, vertex is a word we use quite often, and again, that's either the lowest or the highest point. Axis of symmetry, it's that line, invisible line that cuts your function in half so that it's mirror image or symmetric to itself, and then quadratic function, and you'll see that. So a parabola is a graph of a quadratic function, a function of the form y equals ax squared plus bx plus c. That's considered a standard form. You'll see that again. Okay, and so our main idea here is that it's symmetrical around its axis of symmetry. Notice they're the same on both sides. And the axis of symmetry is a line that's passing through the vertex. A parabola can open upward or down. Again, please be aware it can also open left and right, but we're just focused on up and down. Okay, so now we're going to use our vocabulary. So circle each function whose graph is a parabola. Now keep in mind that in order to be a parabola, there has to be a squared term. So hopefully take a minute, pause, look at this, and then let's circle our answers. So we'll go back here. And I'm going to use this one this time. And okay, this playing with this a little bit. This is kind of fun. So that one, no, I think not. Okay, but this one is, this is a squared term. So we're going to circle that one. This is also a squared term. So we're going to circle that one. Okay, and let's do that. Let's get rid of the last thing. Okay, and so all we're going to do is just move this. Okay, so there you go. This one's not squared, neither is this one. Okay, now here they're asking us to cross out the function whose graph is not a parabola. Again, a parabola is a squared term. So we circled these because they were. Now we're going to cross off the ones that aren't. So let's go back and let's do our cute little lines. So this one is a squared term, so that one's a parabola. This one is not, that's linear, okay? And then this one is, again, this one's not squared, okay? And there you go. Okay, so far so good. Let's go ahead and go to the next page. Okay, so now we're looking at problem number 2. What we're going to do is we're going to graph translations of f of x equals x squared. So remember, if you remember, f of x equals x squared would be our parent function. So that's this blue one here. Okay, so we graph that because this is f of x equals x squared. So they want you to graph x squared plus 3. Now we've gone over this many times, how to use your calculator. If you need help, please ask in class. Okay, so there is the graph, that's the red one, of x squared plus 3. So using those two at the right for exercise 4 or 5. So they want to circle the ordered pairs that are solutions here. And that one should be pretty easy for you to do. You want to circle the ones that go with this one. So circle these points. And then we're going to underline the ones that go with the regular function. Okay, so let's do some underlining here. So I know that that one goes there. It looks like -1, +1. They don't have that one. Let's see. -3, 0, no. Let's see. What else do we have here? Here's 2. Here would be, have any 2s, they have a bunch of 3s. So 3 would be right here. They want to know if that one's part of it. Here, if you have 1, 2, that's -2, that's part. -3 would be right here. Okay, so I think probably for me, if I were going to do this, I would go put this function in and then go to my, you can put both of them in, but then go to my table function and see which ones work. Okay, that's honestly what I would do. I do know that this vertex here is 0, 3. So I'm going to circle that one. Okay, so 0, 3. Okay. And that just looks awful, so let's not make it quite so big. Okay, so we know we're going to circle that one. And then this is 1. So they want you to basically, which ones are solutions, keep in mind they have to be on the ordered pair. So I kind of started you out. And again, I would pick up my calculator and do that. Now, so what you want to do here is then answer these questions. So for each value of x, the value of g of x equals x squared plus 3. Is that 3 more or less than the value? Well, here's the function, and if you add 3, so it would be 3 more. I think that sort of makes sense. Let's underline the word more. Okay. This is translated up or down from the parent function. Translate it up. Okay. And then which one is in red? That would be this one. And the parent function is in blue, because remember it would start at the origin. Okay, so that takes care of that much. Again, please feel free to rewind this as much as you need to. Okay, so let's go this part next. Now what we're doing is we're talking about the vertex form. Okay, so what we're going to be doing is we're going to be identifying the vertex, the axis of symmetry, a minimum, a maximum, and domain and range of the function. Okay, so we're just going to keep going and knock ourselves out with that one. Okay. And then, yep, we're good. Okay. So they want you to compare it to the parent function and identify A, H, and K. So A is the number in front of the parentheses, H is right here inside the parentheses, and K is outside the parentheses. So when we look at this, and like I said, I don't have, well, I have my pencil, but I don't know how good this is going to look, so bear with me. So here, A is going to be, okay, that's weird because here it has a negative, but here it doesn't. So I think it's supposed to have a negative, so let's just throw that in. And that looks really bad. Let's go here, and there we go. That should be a -2. They just didn't have it in. Okay, So A in this equation, what number is in front of the parentheses? That's going to be negative 2. Again, bear with my handwriting, okay, because I don't have my slate. And then H, this says x minus h, so this would be x minus a negative 1, so that's going to be negative, whoops, negative 1. I'm going to erase that and rewrite that. Okay, so negative 1. And then so k is going to be whatever it's there, it's 4. Okay, so then my vertex is hk, so it's negative 1, 4. Okay, and my axis of symmetry is going to be whatever x is. So in this case, or in this case it would be k. I mean, sorry, not k, it's h. So it's going to be x equals negative 1. Okay, because remember that's the line that goes vertically through and it cuts the parabola in half. Okay, so a is less than 0. So that means that it opens what? Up or down. Here's what you need to know. If it's a is less than 0, which this one is, it's going to open down. Okay? So if it opens down, it has a maximum. Okay, so just kind of wanted to clear that up for you. So that means it has a maximum because that's going to be your highest point. In other words, what you're looking at is the graph looks like this. So this is the maximum. A is less than 0, it opens down. If A is greater than 0, it opens up. If it opens up, it has a minimum. If it opens down, it has a maximum. So this has a maximum, okay, of what value? It would be 4, because your maximum or your minimum is your y value. So this has a value of 4 when x is negative 1. Okay? Now, if you need to see this, it really shows really well when you look at the calculator. Okay? And so here, my domain and range. At this point, let's put this on the calculator so that you can see how it looks. So just give me a minute. I'm going to pause this and get my calculator set up. Okay? And Okay, thank you for giving me a minute. So what I've done is I have gone ahead and put it on my graphing calculator. So on the Casio, it should look like this. I made sure I was on a standard window, and so I exit, and so you see I just entered the function there. Don't forget the X. I see that happen a lot. And then I just told it to draw. Okay. And there you go. So that's what it looks like. Now, what I'd like you to see is I also did this on the TI, and here, this is the color one, so one thing it'll be nicer to see. But notice you can see the calculator, you can see what I'm actually working on, but you also see this is the equation, this is the table it generates. I've talked to you guys about the table numerous times, and then this is what the graph looks like. Okay, so now I want you to be able to see that. So this is what it's going to look like. So as you see, I'm actually going to use the Casio really quickly. But as you see, so this highest point, this is going to be your vertex. If you're on the Casio, if you hit Shift and G solve, it's going to give you maximum minimum, and this is a maximum, so I'm just going to hit F2. And it's going to tell me exactly what that point is. And as you notice, it's what? -1,4. But I knew that just by looking at the equation. Now, if you're on a TI, let's see if we can get that one to work. So we're going to hit second and calculate, okay? And we're going to hit maximum, so number 4. Okay, yeah, enter. And it says the maximum is the y-intercept, which that's not true. Let's see if we can make it get off that. Okay, let's try tracing it. Okay. Now let's see if we do it. And the TI unfortunately is kind of weird like that. So, but I'm working on trying to make it. So we're going to hit enter, enter, enter. And it tells me it's -1, +4. As you see, it's getting it, but it's not hitting that exactly. I can try to trace a little more, but it's kind of hard to get it to hit exactly. And that's just one of the things with the TI. But the nice thing is it looks really pretty. But if you look at the Casio, as you see, if you just hit maximum, it'll go right there. If you hit minimum by accident, it's going to tell you it's not found because this would not have a minimum, okay? So that's kind of where we are. So we've identified everything there. Now, you want to look at domain and range. So if I look back here, our domain is all real numbers because notice that this goes on forever, this goes on forever. It just moves very slowly, but you're going to hit you would hit, go on. So we would be looking for what is our domain. It's going to be all real numbers. Okay, it just is. And let's put that there, and okay, there we go. And then they want to know what the range is. Well, let's go back and let's look at the graph. Now, the highest point is where y=4. So your range is going to be, or let's see, it should say y, but on my paper it says x. All kinds of typos. Okay, so that's really weird. Your domain's all real numbers, but this should actually be y is less than or equal to 4. I'm not sure why it says x. So let's just kind of cross that out and put a y. Because guess what? It's this one right there. Okay? And there's my circle. Not half bad. It's huge though. Okay? So that's how that works. This is not very difficult. It's just a lot to remember. So next thing I want you to do is they want you to use, basically here you have 4 different functions and they want you to match them up to the pictures. So honestly, if this were me, I would graph these and see which one matches, okay? But you could also just look at the vertex. Like this vertex is 2, +3. So where do I see 1, 2, +1, 2, 3? Okay, so just so you know, whoops, didn't want to do that. Here, you can say that this one goes here. And this one is -1, -2. So -1, -2. This one, let's undo that and let's do it a different way. Okay, we're going to call this one 1, this one's 2, this one's 3. That's horrible. I missed my slate. And that one's 4. So we already said this one is 3, so it's going to go here. Yeah, that's just awful. Then we were looking for -1, -2. So 4 is going to go there. We need -3, 0. So -3, 0. So this would be 1. And then this would be 2. All I did was look at the vertex. That was actually made it really easy to do. But like I said, the flip side is you can always just, plug in the right one. Let's see, and yes, and got them all right, just a heads up. Okay, so next go to the next piece. Okay, using the vertex form. So what you want to do is you should be able to look at the vertex form and see all the changes that were made. Okay, so our function is f of x equals 2 times the quantity x plus 2 quantity squared minus 5. Okay, how is that different from the parent function? Okay, notice that there's a 2 in front, so a is greater than 1, which means it's a vertical stretch. Okay, so stretch by a factor of 2, they all say that, so that doesn't happen. This says I've reflected around the x-axis, and this says I reflected around the across the x-axis. Well, I didn't, because if I reflected across the x-axis, this actually opens up because this is positive. There's no negative, so it's not opening down. So I can basically say no and no. Okay, so I'm left with this one and this one. Okay, let's see. The vertex is -2, 5. So from the parent function, I should have moved left and then down. Okay, so from the parent function. So remember, this is -2, so I went left and down. So where am I going? Okay, that's not, it's either this one or this one, which I already know it's not. So left and down, so that means it's this one and it's this one. Okay, and again, just using what you know about the vertex, notice so far I just used the vertex to pretty much figure out everything I needed to figure out, with the exception of maximum and minimum. But if you remember, maximum and minimum are always your vertex already, so we're good there. Okay, so let's go to the next piece. So now what they're having you do is they want you to, the graph shows the jump of a dolphin. The axis of symmetry is x equals 2. The height is 7. Okay, so if the path of the jump passes through the 0.55, how do you basically get the equation, is what they're using that to do. Okay, and so that's actually not that difficult. Let me show you. So we know what the vertex is. We know it's what? 2, 7. So we know what the vertex is. So let's fill that in. And I'm saying it because the handwriting is terrible. So that's 2, 7. So I know that this is 2, 7. So the only thing I don't know is I don't know what A is. But I'm going to use the extra point that they gave me, and I'm going to use that to find A. Okay, so let's go and do that. And let's go to the next page. Alrighty. Okay, because my handwriting is really horrible right now, I'm going to pause and I'm going to show it to you all written out. So give me just a minute. Okay, so now what you're seeing is we already had this, the 2 and the 7 already put in. And so we used the x and y that they gave us. So we're going to replace x and y, both of them with 5 because they happen to be 5, 5. And then you just solve the equation for A. So what we did is we simplified here. So this is 3. And 3 squared is 9. So that's where they got the 9A. You subtract 7 from both sides. So you get -2 equals 9A. and then divide both sides by 9. So a is negative 2/9. And so the equation that would model that is f of x equals negative 2/9 times the quantity x minus 2 quantity squared plus 7. So again, we found the h and k because that was our vertex. We used the point that they gave us. We substituted into the equation and used that to find a. Okay, so we did 5 minus 2, which is 3 again. 3 squared, that's where the 9. Here's the a. There's the 7. Okay, and then you just write the equation. So guys, we're almost done. Okay, so basically what you're doing, and let's pause. Yeah, I was just talking and I'd already paused it. Okay, so we wrote that in, and so what you're seeing here is, when does the graph of a quadratic function have a minimum value? Okay, which one has the minimum value? It's this one right here. That one has a maximum. Okay, this graph, y equals x squared, is a parabola that opens upward. Y equals negative x squared would open downwards, which would be that. So when does the graph have a minimum value? And I would expect you to figure that out, okay, just by knowing the information that we've talked about. And then that pretty much takes care of the notes. So these are the words that we talked about. Hopefully you'll be able to check these off and say, yes, I understand. And then I'd like you to rate yourself and kind of let me know where you're feeling. So that's the end of this video, and I will see you on the next one.